Okay, we're on problem number one. It says find all the zeros of the function. It's going to require factorization. It's a fourth-degree polynomial, so I'm going to resort to the rational root theorem to find two roots and then use long division to find the remaining two. All right, so you could go through discard rules, sign, things like that, but I don't think that's going to be productive at this point. I think looking for a rational root may be productive. All right, so let's write this down. Number one, we have a polynomial function. It's a fourth-degree polynomial. We're expecting to find four roots. These are real coefficient polynomials. Again, expecting to find four roots. The first thing, you just use a rational root theorem, and write that in the potential roots of it. It's going to be plus or minus the factors of 6, which would be 1, 2, 3, and 6, and then the factors of 2, which would be 1 and 2. All right? Now, granted, I don't want to write every possibility down, but I want to start looking at them, right? Like, for example, you might say, oh, let's just try 1, or -1, or 2, or -2. I'm kind of looking and getting a feel for it. And I'm going to say it looks like f of 2 might work out for me. Put this down for you. And by working out, I want to see if it's equal to 0. So let's write this down. So it's going to be 2 times, 2 to the fourth power is 16, minus 9, 2 cubed is 8, and then plus 23 times 2 is 46, minus 6. What do you get over here? 2 times 16 is 32. Let's see, minus 72, and then plus 46, minus 6, which is 40. What else? 32 and 40 is 72, and 72 minus 72 is, of course, 0. So now I found one factor of the problem. And what factor did I find? If the root is 2, the factor is x minus 2. All right? Now, granted, I don't think I'd try 3. And I certainly don't want to try 6. I'm going to start trying fractions now. And, looking at it, that's a tough one, isn't it? I'm going to look at the fractions, but I'm going to go negative. And I'm going to put f of minus 3/2 down. And again, I'm hoping it's going to be 0. All right? Now, where's that coming from? 3 over 2. And what do you get there? You get 2 times, I have to put that to the fourth power, by the way. That's going to be 81. And then 2 to the fourth power is going to be 16. Right? And it's going to be plus now. 9. And that's going to be 27. And that's going to be 8. Let's keep going. Minus, let's see, 3 times 23 is 69 over 2 minus 6. All right, let me just see if I can simplify a little bit. And it's going to be 81 over 8 plus, I'm going to put down actually 3 times 81 over 8. I'm sorry, 6 times 81. I'm sorry, it's 6. That's 3. I'm sorry. I'm daydreaming. Let me get my eraser out. Erase this business over here. And let's take a look. I lost track. Oh, I'm sorry. I'm doing the 9 times 27. So I'm going to borrow 3 from the 9. That gives me 3. And 3 times 27 is 81. And then I get minus 69 halves. I can put down minus 12 halves here. Let's see what you're going to get. You can get 4 times 81 over 8. And this is going to give you 71/81 minus 81 over 2. What do you get over there? 81 over 2 minus 81 over 2, and that equals 0. So now I know there's another, by the way, minus 3 has a root. I know there's a factor. And what does that mean? It means x plus 3/2 is equal to 0. Multiply both sides by 2. You get 2x plus 3 equals 0. So write that down. 2x plus 3. And again, what I don't know is I don't know what goes here. Right? There's many ways to do it. Equating coefficients is one way to do it. But what I'm going to do is I'm going to do a long division now. And I'm going to divide this into this. And I'll get this over here. All right? So what's x minus 2? I'm sorry, what's x minus 2 times 2x plus 3? It's going to be 2x squared plus 3x minus 4x, which is going to be minus x. I gotta be careful there. So that's 2x squared, 3 minus 4 is minus 1, and then minus 6. And I gotta do a long division. So 2x squared minus x minus 6. Let me just look back and make sure I copied that right. 2x squared minus x minus 6 divided into 2x4 minus 9x cubed plus 23x. You know, I noticed right off the bat that's a place is missing over here. So I'm gonna put it in. Not that you have to. I'm gonna put it in because for students that want to do it. So there's actually no x squareds. And then 23x minus 6. All places are being held now. Let me just make sure I copied the right thing. 2x4 minus 9x cubed, 23x minus 6. Let's start dividing. And certainly if I do this correctly, I'll get a remainder of 0. So what times 2x squared would you? 2x4 would be x squared. I'm going to put this over here. Got a nice column for it now. What do you get? 2x4 minus x cubed minus 6x squared. And this is where most students screw up, by the way, the subtraction part. So let's put this down. So it's going to be minus 8x cubed plus 6x squared plus 23x minus 6, and repeat. What are you going to get over here? Minus 4x. That gives you minus 8x cubed plus 4x squared, and then plus 24x. Subtract. What do you get? 2x squared minus x minus 6, and now I see it's going to be plus 1 now. You get 2x squared minus x minus 6. And that went smoothly, as expected. I got 0. So I got my f of x. Let's write this down again. What's f of x going to be? It's 2x4 minus 9x cubed plus 23x minus 6. Using the rational root theorem, I found 2 of the factors, and one was x minus 2. The other one turned out to be, I got to remember now. Let's go back over here. 2x plus 3. And now I got this quadratic factor I just determined, which does not look factorable over the integers. So what do I do to get those roots? I have to use the quadratic formula. So let's put this down. X squared minus 4x plus 1 equals 0. X equals, let's see, twice the a, that's 2. Opposite of b, which is 4, plus or minus. And what do you get there? The b squared, which is 16, minus 4, times a, which is 1, times c, which is 1. So what do you have here? X equals 4 plus or minus. This is the square root of minus 12 over 2. Let's keep moving. You get 4 plus or minus. Well, there's a minus 4 there, so it's going to be 2i. And then you're going to get a root 3. What do you get on bottom? 2. This seems to be pretty nice. You get x equals 2 plus or minus I root 3. So we got our roots. And that's what the question was. Number 1, it says find the roots. So let's put the roots down for you. I'm going to say the first one I put down, let's just review what we got over here for roots. We found 2 and minus 3 halves. I'll put those down first. 2 and minus 3 over 2. And then I got these complex ones, which is 2 plus I root 3. And the other is going to be 2 minus I root 3. That was their question. This is their answer. I think the worst part of this problem over here was the rational root theorem and testing the roots out. So minus 3 halves 2, 2 minus root 3. Make sure I did that right, by the way. Oh, you know what? I made a mistake. I just noticed it. I said minus 12. I got to erase something now. And this happens to me sometimes. I make a mistake. And let me erase this over here. And let me erase this up here too. This is all wrong. I'll erase everything. Start again. Got it correct. All right, x equals 4 plus or minus, that's root 12. I said minus 12 before. I don't know why I did that. 16 minus 4 is 12 over 2. X equals 4 plus or minus, the square root of 4 is 2, so 2 root 3 over 2. And what do you get? 2 plus or minus root 3. 2 plus or minus root 3. Let's write the roots down again. So the roots, whoops, I did it again. The roots, let's write this down. I gotta go remind myself here. We have 2 and minus 3/2, okay? Put those down first. And the other root's gonna be 2 plus root 3. The other root is 2 minus root 3. All right? Okay, I think that's it, and we'll go on to the next question. Thank you.